Welcome back to lesson 41, rate of change. So before we jump into today's lesson and look forwards, I do want to recognize that rate has a connection to ratios, and we're still looking at the change in y and the change in x. However, in this case, we're looking at the change of whatever our output is, whatever it is, whatever our y values are, over some type of time interval. And time is our x, our input. So in this period of time, what is changing? That's what we're going to look for. So here we go. We're going to try to identify the interval that the question is asking for. Sometimes questions are going to be very specific. From this point to this point, in this interval, what was the change? To do that, we're going to identify 2 points from either a table or a graph. So it looks very much like slope, where we were identifying just 2 given points on the line. And then we're going to substitute the values using the slope formula and simplify. So we're still, to find the rate of change, we're still going to use our slope formula. And then finally, label our answer with the appropriate units. We're going to come back to this question, this problem with Craig. Remember, he was on that driving trip, and we saw when he was on the highway and in the city, we tried to make some guesses and figure out what happened during the intervals of those sections. So here's our question for today. We're going to determine his average speed to the nearest tenth for the entire trip. So looking at this, the entire trip, this is our interval. So instead of going from A to B, B to C, C to D, D to E, we're talking about literally from this point, from 0 hours to 7 hours. That's our time frame. Over these 7 hours, what was his rate of speed, the average speed? Now, I've seen kids do different things. I've seen a lot of students go and find the average for each interval because their mind sees it in pieces and wants to chunk it out, and they feel this will make it easier. And my advice is we don't have to do that. Instead, what we can do is we can take the beginning and the end and identify that change in y using just those 2 points. Watch what I do. So I'm going to put in my rate of change formula, which looks exactly like our slope formula. y2, y1, x2, x1. Because time moves forward linearly, this is our first point and this is our second point. So let's substitute those points in there. So this point up here at hour 7, he's driven 230 miles. And at our initial point 1, we're just at 0, 0. Okay, so let's put this part in. So we have 230 minus 0 over 7 minus 0. And that simplifies to a very easy 230 over 7. Now we have our ratio. However, we don't express it in this way. We're going to have to do some simplifying. So let's find the average. And we're going to divide these out. 230 divided by 7. If you have a calculator, you're going to get 32 and 857 thousandths miles per hour. That's our units, because we're talking about miles traveled over hours. Matter of fact, let's put that into our units. He drove 230 miles in 7 hours. Let's add that in there. All right, but our question did ask us to round to the nearest tenth, so we have to do that. And so our final answer is 32.9 miles per hour. And that's it for rate of change. We just took 2 points from the interval. We took it from the beginning of the interval and the end of the interval. And you may be asking, can you choose any point within the interval? Not for this type of problem, because we're not looking for one section, because we can see how much the speed changes. If I took these intervals, this part from here to here, this would be a different rate than this one where he's driving slower. So instead, we're figuring out the average of all of these points by using the start and the end. Hit pause and jot this down. I also recognize there's one other way that could work since we're talking graphically, so I'm going to share that as well. Let's clear out the page. We know what the time interval is, starting from hour 0 to hour 7. So 7 to 30. Let's put that in there. So we could use our change in X, change in Y, and use our triangle type theory. So watch, starting from this point to this point, even though it is not a constant change, I can create a triangle. Here we go. And what I'm doing here, no, it doesn't look like a triangle. I have 3 points. I can find this change of Y here. So it went from 0 to 230, so that's 230, up 230, and it went from 0 to 7, over 7. So here's 230 over 7, and this would also work, which was simplified to the 32.9 miles per hour. However, this doesn't really show a lot of work and won't always show that you understand that the rate of change is an average and that it's not a slope. So I do want to make sure that we're using these coordinates and these points in order to demonstrate our level of understanding. For our last example, we're going to use a table, and we already have coordinates here. Here's our question. A family is traveling from their home to a vacation resort. The table shows their distance from the home as a function of time. Determine the average rate of change between hours 2 and hour 7. So here we have our interval. And so we're going to find that rate of change. Okay, so let's just identify them. I'm looking at my graph, and here is hour 2, and here is hour 7. So here's my first set of coordinates and my second set of coordinates. Substitute. Let me also put this down. We have our X as our Y. Our time is X and distance as Y. I want to make sure I put that in there as well. So 480 minus 140 over 7 minus 2 simplifies to 340 over 5. And these units represent 340 miles per hour. Great. Let's simplify that out. 340 divided by 5. Just make sure we've written that as 340 divided by 5. If you use your calculator, you'll get 68. And we have to make sure we have our correct units, miles per hour. No need to simplify. We have this in simplest form, no rounding. We have our final answer here. And that is it. So great job for today. I hope you found this really helpful. Again, our rate of change formula is going to feel very familiar because we use the same method when we're calculating slope. Our big key is to make sure you're identifying in the problem what is the interval that you are working with. That will give you your y1, x1 coordinates and your y2, x2 coordinates that you can easily sub in, simplify, and solve. That's it for today, Math Marbles. I'll see you in the next one. Be well.